In this video, we're going to go over the first step of duct design, your equipment selection window. To get to the equipment selection window, you can go to the Show menu, select Equipment, hit the F7 button on your keyboard, use the Equipment icon button on the toolbar at the top of the page, or the Equipment button here on the navigator bar. Note that if you have the right dollar tool, this will take you to our operating cost comparison page. Within that page, clicking the button with 3 dots will allow you to select several pieces of equipment for the purposes of comparison. The equipment that will be used in your duct design will be the one that you have selected at the top of the column here. For the purposes of this design, I'm simply going to use the Show menu. Now, for more information on the proper way to select a piece of equipment, check out some of our other videos dedicated to the equipment selection window. Our focus is going to be on the duct design components. Now, for the purposes of this video, I'm going to select a split air source heat pump. This is going to allow me to see both the heating and the cooling side airflow values on one page, so that I won't have to flip between a cooling system and a heating system. My backup will be electric strip, and I'm going to eliminate water heating. That will take me directly to the split air source heat pump page, or split ASHP. Now, strictly speaking, for the purposes of a duct design, all I need to do is focus on this box right here. But there are a few other elements that we should consider. If you're using Wrightsoft to select your equipment using the Select Equipment option here in the bottom left-hand corner, there might be some additional information provided about the airflow capabilities of your system. For example, if you're selecting equipment from one of the manufacturers that Wrightsoft has Manual S data for, and you choose the option that says Select for Manual S, the equipment available on the list will be sized at a particular air volume, meaning that the design CFM listed here, and therefore the design CFM listed on this page here, is going to be specifically calibrated to meet Manual S requirements based on your load calculation and the manufacturer's extended performance data provided to Wrightsoft by that manufacturer. So if you've used Wrightsoft's Manual S selection tool, the cooling and heating CFM numbers are more than just an estimate. These numbers are the CFM values which will create the proper conditions for this particular piece of equipment to meet your load. In other words, in order to have the right amount of sensible and latent cooling from this heat pump, I'm going to need 1200 CFM moving through this system. Now, unfortunately, at the time of this recording, none of the manufacturers who are providing their extended performance data are also providing static pressure data. So I'm going to be responsible for determining at what static pressure this fan can deliver 1200 CFM at the desired fan setting that I'm going to design for. If I choose not to select a piece of equipment using Manual S data, if I simply hit the Select Equip button in the bottom left-hand corner, find the equipment that I want to select, and click OK, the equipment data used is all based on AHRI data, which doesn't necessarily tell you the needed CFM to create the ideal operating conditions of that equipment. Bottom line, even if I have select equipment from Wrightsoft's equipment database, given that most of the data is AHRI data, if I'm not using the Manual S features, I, the designer, am still responsible for providing this CFM information here. Prior to selecting a piece of equipment, the CFM is being calculated based on a Manual S formula for estimating CFM. After your equipment is selected, given that it's based on AHRI data, Wrightsoft will automatically assume a 400 CFM per ton air volume. That is to say, your 95-degree capacity divided by 12,000 to determine nominal tonnage multiplied by 400. You can change this number by overriding the field here or by entering the CFM in this field here. If I choose to design this system for 1200 CFM rather than 1127, I simply need to change it here, or with the F8 key on the keyboard, here. And again, in this case, I'm still responsible for setting the static pressure value as well. Now, you might find yourself designing a duct system prior to selecting a piece of equipment. Should you find yourself in a situation like this, you might use the Manual S's estimated CFM value here. Or if you have a general idea of the CFM you'll be moving through the system, but not the actual model numbers of the system yet, you're still going to need to visit this page to set your CFM values and your static pressure. If I know, for example, that I'm going to be moving 1000 CFM through this system, I can override this field here or enter the information in this field here by using the F8 key and entering 1000 CFM. Now, I'm still going to be responsible for, in this case, estimating the static pressure at which the fan that I'm going to choose will be able to deliver that 1000 CFM. At the end of the day, it's these two numbers, the CFM you'll be moving through your system and the static pressure conditions under which your fan can deliver that CFM, that makes the equipment selection screen the first step of the duct design process. Now, speaking of those CFM, we do have one other option here that we can exercise. The default setting in Wrightsoft is to use a heating equals cooling design, meaning that your heating CFM will be based on your cooling CFM. Your heating static pressure will be based on your cooling static pressure. This is a common design tactic in a situation where your heating and cooling CFM may be variable, but your ability to seasonally balance a duct system is significantly hampered. Using a heating equals cooling design will ensure proportional design for any individual duct runs that might call for more heating or cooling CFM. If you want to adjust individual heating and cooling airflow needs, simply uncheck this box. You can then manually adjust both the heating and cooling CFM and static pressure numbers separately. This can be useful for situations where seasonal balancing is attainable and in situations where you want to base your design on one over the other. For the purposes of our videos here, we're going to use a heating equals cooling design option. There. Now once I click OK and move on to our next step, our static pressure losses page. This concludes our first step of the residential duct design process. Thank you for your time. Have a good day. In this video, we're going to have a look at the second step of the residential duct design process, the static pressure page. You can get to the static pressure page by going to the Show menu, going to your right D or right duct tools, and selecting static pressure, by clicking the duct button on your navigator bar and selecting static pressure, or clicking the right D toolbar at the top of the page and clicking the blower icon here. Now once you're on the static pressure page, you should notice that the external static pressure has carried over from your equipment selection window. If you don't have information in the external static pressure window, go back to your equipment selection window and fill in both your CFM and static pressure from step 1. With this information on this page, we can now isolate the amount of resistance to be used for our duct design. You see, ductwork won't be the only thing resisting airflow, and since we're designing the duct system to achieve a certain amount of total resistance on the fan, we need to remove those things which are going to add to that resistance that aren't ductwork. For example, your coil. Now you may or may not have a coil loss. For this example, I'm using an air handler, and many air handlers are rated with a coil in them. However, some of those coils are rated dry, meaning there'll be an additional adjustment factor for a wet coil, and depending on the unit, that adjustment factor might be different. This is something I need to look up in my manufacturer's technical data. Now, some air handlers are going to be rated with a wet coil already in them, meaning there wouldn't be any pressure drop at all. Now, if this were a furnace situation or an air handler with a secondary coil or hot water coil, I would have additional pressure drop for that as well. There are no standard values for coil pressure drop. This is definitely something you're going to want to look up in the manufacturer's technical data. Just a cursory look through some of the technical data, we see pressure drops as low as 1/10 of an inch all the way up to over 5/10 of an inch of pressure drop, depending on the amount of air flowing through a particular coil. Now for this example, I'm going to apply a wet coil adjustment of 0.07 inches of water column. Now my heat exchanger is something that typically in a furnace situation I wouldn't need to adjust for. Furnace heat exchangers are most likely going to be included in the static pressure ratings of your manufacturer, but it's always important to know what those assumptions are, so for final word on this, check your technical data. Air handlers, on the other hand, most likely don't include the static pressure loss from a strip heater, and depending on the size of that strip heater and the amount of airflow you're moving through it, you'll have different pressure loss numbers here as well, and they can become significant at higher kW and higher airflow values. I'm going to use a pressure drop here of 0.05 inches of water column. Now supply diffuser and return grill pressure drops are something that you can look up as well. I'm going to use the manual D standard 0.03 pressure drop for both supply diffusers and return grills, leaving you with a filter pressure drop. Now filter pressure drop can get very high and can make designing a proper duct system a very difficult task. be sure to know what your actual filter pressure drop is on the amount of air moving through it. Some people would be surprised at the amount of resistance a 1-inch pleated filter could provide on their system. Now I'm going to use a very low reasonable pressure drop number on a high surface area filter of 0.1. This number can be much higher, but for the purposes of this design, I'll say I'm picking a very low restriction filter for this design. I don't have a humidifier in this design, so I'll leave that out. And a balance damper, I will use again the manual D standard of 0.03, leaving me with a total available static pressure of 0.19 inches of static pressure. Now what this number means is I have 0.19 inches of resistance allowed for my ductwork. In other words, the worst case run of this duct system should create 0.19 inches of resistance overall on the fan, causing the right amount of airflow to come through said fan. This ultimately is what a friction rate is all about. After you've designed the duct system and Wrightsoft has calculated not only the actual length of each duct run, but the additional equivalent length of each fitting your air is moving through, we will have a total effective length number. Based on that number, Wrightsoft will be able to create and use a friction rate that creates an available static pressure, 0.19 inches, which in turn, after all of the other resistances, will create a total static pressure of 0.5 inches in this case. With an available static pressure of 0.19, a friction rate of 0.1 would be created if I had 190 feet of total effective length of run. Once our available static pressure is set, we're ready to move on to the next step of our duct design process. However, we will be back to our static pressure page to find out what the actual design friction rate of our system is and to determine whether or not it's within the acceptable range. Thank you for your time and have a good day. In this video, we're going to have a look at the duct preferences page. We can get to the duct preferences page by going to the show menu, the right D or right draw tools, duct preferences, or clicking on the duct button on the navigator bar and going to the preferences page, or clicking on your right D or right duct tools here and clicking on the set of gears here. Now, once on the duct preferences page, the most important and useful thing to note is that this entire page can be saved as a library, so that one can flip from one group of settings to another very quickly and very easily by simply creating a library option and then selecting that library option here at the top of the page. And when setting up the duct preferences page, I strongly recommend that rather than going through the entire page here, one invest the same amount of effort and create a library of these settings here. So I click on the button with 3 dots next to the duct preferences library here at the top of the page, and I click the next button. Now, given that this is a library that can be set up in advance, it's possible that during the Project Wizard process, you've already selected the appropriate duct preference library. Assuming that you haven't set up a preferences library yet, so I can create a new library and click the next button at the bottom of the page. Now here we can choose the layout of the duct system. We're going to draw our own duct system here rather than have the program draw one for us. A radial system would be every duct connected with a home run off of the air handler. The one-level trunk systems have a trunk line on the floor with your air handler, and everything else runs up a riser at the end of the branch runs. The plenum systems have a main riser off the top of the air handler, and it's a separate trunk on each floor. X-axis systems, the trunk goes left to right. Y-axis systems, the trunk goes up and down. Again, we're going to use user-defined as our default. The max supply branch heating and supply branch cooling determines how many registers a room gets by default. You can add and delete registers very easily on the drawing screen, so I'm not going to tinker with that setting either. The duct size, we recommend using standard English sizes for most designs. This will eliminate odd sizes after 10 inch. We'll also eliminate odd sizes in rectangular duct. Automatic trunk reduction, up to you. The program will reduce your trunk line when the velocity in the trunk drops by 50% if you check that option. Use variable friction rate. We'll calculate a different friction rate for every individual run of the duct and size each component for its worst case friction rate. So that a branch run with lower restriction would use a smaller duct, and a branch run having to deal with higher restriction would need a larger duct. And you would get those sizes yielding a better balanced system as a result. A bypass duct can be calculated on the duct preferences page. Bi-level zoning is a specific type of zoning to accommodate hot air rise. Checking that box, the cooling CFM will be increased by 20% on the second floor, or the top floor, I should say, and the heating CFM increased by 20% on the bottom floor. All right, I'm going to leave that unchecked for now. Down here we have a breakdown of the actual ducts, both supply and return, branch and trunk. I can choose the material of the duct system. This, of course, is going to be the actual interior material. If you have a sheet metal duct but it's lined, you would be selecting duct liner and not sheet metal. And note, any sizes that we calculate would be ID, or interior diameter, not OD. So I'm going to select sheet metal duct system for now, although our design examples will we'll use both. The duct height, if you have a rectangular duct, set a height. If you have a round duct, like I'm going to use a round branch, you leave the height at 0 and we'll calculate a round branch. Even if this says rectangular here, you're still going to get a round size because the duct height is set for 0. Okay? When you set a height, we will calculate a rectangular size. And rectangular sizes, as you probably already know, can be for rectangular or oval. 8 by whatever the size would be could be a rectangular size or oval size. That's where the selection comes in. And I'm going to have rectangular trunks, not oval trunks, so I'm going to leave that there. By the way, a branch is any duct that ends at a register. A trunk is any duct that ends at another duct. The maximum velocity is going to be maximum allowable velocity, this of course being a noise control issue for both supply and return. The minimum velocity is something of a tricky number. Minimum velocity is a number that will be used in an undesirable situation. Should your friction rate be so low that your duct design is using larger ducts than you would like, and there's nothing that can be done to adjust your friction rate, Wrightsoft will ignore the pressure concerns of your duct size and resize the ductwork for this velocity to avoid depressurizing your duct system. Of course, what that means is you are actually reducing the airflow or increasing the restriction on the system past where it's recommended you design it for. But this is about making the best of a bad situation. 200 is a pretty common practice. Some people eliminate this by setting it to 0. Minimum diameter, that's the smallest duct I would use. In the case of a rectangular duct, minimum diameter actually means minimum width. So if I wouldn't reduce past an 8 by 8, then I can set my minimum, in this case width, to 8. The round duct sizes library and rectangular duct sizes library is going to get its own video, so refer to that video if you want to use one of those options. You can select that option. Insulation, this is for our materials list tool. If you want to have a certain material duct show up on the bill of materials, you can choose low, medium, or high insulation duct. The actual R value of those is entirely up to you, as this is only for our materials list tool. It is not for the duct load. That has already been calculated. Register shape and size, you can determine default register sizes here on this page, and the default register sizes are what's going to show up on the drawing screen. Now, these are not calculated grill sizes. We do not know the free grill area, face velocity, Q rating, or other factors about your grills, and therefore cannot size the grills for you. And so this will set a default size throughout the drawing, then allowing you to adjust whatever registers might need to be adjusted. I like to put in a size like this one, 12 by 12, as it makes for larger grills that are easier to click and drag and drop, and I'll be able to more easily tell which grills I've sized myself and which ones I haven't, because I don't typically use 12 by 12 grills. On the return side, I use a similar tactic. 24 by 12, nice large targets, but a pretty non-standard size for my return grills. So it's easier to tell which ones I've sized myself or not. Not to mention, these are two different sizes, making supply and return even easier to tell apart. Of course, we already use industry standards / and X notation for return and supply, but this makes it easier to tell them apart. The register type and material is still for the materials list tool, not for the design itself. We're not sizing the registers. We will, however, pull particular registers and put them on the bill of materials, and of course this is something that can be set on a grill by grill basis, but there's a default setting here that I could use ahead of time. If I click on the next button at the bottom of the page, this is where I can go through and set up my default fittings. Now this can be a time-consuming process, as there are several pages of several different kinds of fittings that you can select from. But the important thing to keep in mind is, number one, if you set this up in advance, you don't need to go through this process every single time. This will be saved as a library and therefore available from one project to the next. And number two, you needn't worry about the fittings that don't apply to this particular system. In other words, this is a sheet metal, trunk and branch system. I don't have to pick flex junctions. I'm not even planning to use flex duct in this system. What you're going to do is you're going to go through each of these pages of fittings, and for any type of fitting that might apply, like supply boot would obviously apply to any of my systems. I could click that button there, the button with 3 dots, and go through the list of fittings, looking at these pictures, trying to determine what type of fitting best describes my most common boot. Now, if I use 2 different boots, I'm going to describe this as the most common, and any one that's different, I'll make a change to after I've drawn the duct system. Now, the primary concern here is you're looking for the picture of the fitting that you use. Now, there may be some sub-options after that. We'll see a couple examples of that in a second. If you cannot find a picture of the boot that you use, or whatever type of fitting it is you use, we recommend that you find something of a similar equivalent length. Look at the manufacturer's materials for whoever it is you buy that particular fitting from. They may have a rated equivalent length for that fitting that you can use. If the picture doesn't match but the equivalent length does, that's ultimately all that matters. So I'm going to click OK. That'll be my supply boot. I could do the same for return boot, and so on for each of these types of fittings. Now, some fittings are going to have one picture with multiple options. For example, elbows can be actually one of the trickier of the bunch, because within the elbow selection, while I may have a radius bend elbow, the measurement of the radius of that elbow, whether it's a sweeping radius or a very tight radius, is going to change the rating of this radius elbow. And so finding the one that has the right radius to width ratio is going to be up to me. Even though there's one picture, the additional information is something that Wrightsoft cannot measure, and therefore something I need to select. However, for the case of a lot of these fittings, like the takeoffs, when there's only one picture of a fitting and multiple options here, often it's the case that these are options that Wrightsoft can measure for you. For example, how many distribution branches downstream is a takeoff is something that Wrightsoft can very easily know and can select. So is the difference in CFM from the trunk to the branch component, or whatever it is the measurement is, we can measure that and determine which of these you want. So all you have to do is pick from the picture saying, this is the fitting that I'm going to use, okay, and we will automatically determine that for you. On occasion, you may see more than one fitting in the same picture, such as this fan fitting here. Right? There's a 1A and a 1B. There is also a case where you're going to want to make sure that you select the appropriate one. And if it's not clear which is which, you can read the description here and see that one is tapered, one is not, one is with a transition, one is not. And so you're going to go through each of these fitting preferences here, determining what the most common fittings are. And this is a very, very important process, by the way. If I'm using a full-size plenum and tapping off the side of it with this rectangular duct that's smaller than my plenum, it's a 35-foot equivalent length. Even without a transition, it's only 35 feet. Whereas if I just tap into the bottom of my trunk, it's 120 feet of equivalent length. That's saying that going through here is the equivalent of running 120 feet in a straight line versus 35 feet. So going through and make sure you pick the right fittings is a very important part of the process. It's something that we can also fine-tune in the drawing screen, but this will certainly make that process a lot easier by picking the stuff out ahead of time. And when I click Finish, I can save my changes. And when I'm done with that, next time I go to do a design using these settings, I just simply select it from the list, and I'm ready to go. So setting these up as a library is probably the most useful thing you can do with your duct preferences, but it is a very important part of the duct design. The one other very interesting and very useful thing about the duct preferences page is that if you change these settings after the fact, anything in your duct design that you have not manually changed will automatically update with your new settings. And so if you pick out a new takeoff, for example, any takeoffs in your design that you haven't right-clicked and manually adjusted will automatically use the new takeoff that you've selected on your duct preferences page. This concludes our video. Thank you for your time, and have a good day. In this video, we're going to have a look at the residential duct design process, preparing the drawing screen. We've already visited the equipment selection window and set our CFM and static pressure. We've visited the static pressure page and entered our pressure drop information. We've been to the duct preferences page and set up our duct preferences. And now it's time to visit the drawing screen, and now it's time to visit and prepare the drawing screen. Each sheet of this building, or each floor of this building, is comprised of different layers. For more information on this, check out our video on sheets and layers. If I want to look at the different elements of my duct design, I need to turn on the duct layer to see the actual components, and the duct notation layer to see the CFM and duct sizes. And when I turn on both of these layers, I can see my duct system. One tip for designing a duct system: you may find it easier to work with the elements of your duct system if you isolate them by locking your building layer. Now if I accidentally miss my click, I don't select or move or drag any of the rooms. I can also use my selection tool here inside the house. So let's have a look at the different elements of our duct design tool. Here in the first room that I drew, I see that I have an air handler icon. The air handler will typically show up in the first room that you've drawn. Sometimes this air handler will go missing. This usually happens when you move the first room that you drew. For instance, if the first room that I drew was in the upper left-hand corner of my drawing screen here, and then I realized that this was too close to the margins and I drag this down here, you will often find that the air handler remains in this general vicinity here. Now, if need be, you can reset the air handler icon by dragging and dropping this shape from the HVAC shapes. However, this comes with a warning. Dropping in this blower icon into your drawing screen will reset all of your equipment information, including model numbers, performance information, CFM, static pressure, and all of your pressure drop data. So I would look for the air handler first, and again, you'll find it in the place where you drew your first room. The air handler itself can be stretched or dragged to a different location. So I can move the air handler where I want it. And this air handler here looks a bit like an upflow unit. If I stretch it out, I can make it look more like a horizontal unit. It should be noted that for the purposes of this design, this air handler should be thought of as both an air handler and the attached plenum, especially for all flex designs. I don't need to draw a duct representing the plenum. All I need to do is perhaps stretch out this air handler icon or calculate the plenum on the air handler's property sheet and simply connect to the air handler icon here itself. No need to worry about a plenum. And when I look at the property sheet for this air handler, I can see the general information, such as what floor the air handler is located on. So if it shows up on the second floor, it should be on the first floor, or vice versa. I can change that here. It tells me what zone it belongs to. If I have separate air handlers for different zones in this house, it will identify itself there. Supply system color and return system color. I don't like to use these tools until after my duct design is done, as I find the color coding per floor system a useful piece of information, knowing what floor I've drawn my ductwork on. If this is a high velocity duct system, I can turn that on. We'll have a separate video for that. The duct layout, if you wanted to have an automatic duct layout, you could select one of these here, although I do like to use the user-defined method and just draw the ductwork myself. If we look at the static pressure information and CFM information for both heating and cooling, this is an output page here. And I can go to the plenum tab. As mentioned, this icon represents both the air handler and the plenum, and so I can have a tool that will help me size a plenum. If I put in a height and a length, it will calculate what the minimum width is going to need to be. I can do that for both supply and return. Entering plenum information here will add that to your bill of materials as well. In addition to the air handler icon, we have two other icons here, both of them grills, supply grill and return grill. Now, if I click on the supply grill here, I can drag and drop that grill wherever I want it to go in my design, just like so. I can right-click on that grill, and I can find out more information about it. It tells me what room it belongs to here. Asks me if it's existing. An existing component is one that won't be on the bill of materials. So if I designate this as existing yes, it will continue to calculate here on my design, but my bill of materials tool will not pull that particular part on the bill of materials. Register type, this is again for the bill of materials. Register material, shape, width, height, all of this is going to affect the bill of materials, but this will also affect the notation on the drawing screen and how it looks on the drawing screen. If I want to change this grill to a 12 by 6 grill rather than 12 by 12, or if I want it to go the other way, I do have the ability to rotate a grill, or using the drawing menu, rotate a grill. But rather than rotate this 90 degrees, I could also just make this 6 by 12 instead. Default airflow arrows, if I turn that to no, I can choose what type of airflow arrows, what directions I want, so I can indicate the throw of the grill. I can enter the rotate angle here also on the property sheet, and I can reassign this supply grill to different return grills on the property sheet as well, although there is a much easier way to do that we'll go over in our next video. And so I'm going to place these grills where I want them to go by dragging and dropping these grills where I want them. And in any area I want an additional supply grill, I simply use the HVAC Shapes toolbox. Now, if you followed my advice and locked your building layer, you may find the HVAC Shapes toolbox is gray. Select a layer that's not locked, like the duct layer, and you'll be able to access the HVAC Shapes box again. This is a supply register icon. Simply left-click and hold, drag and drop, and the program automatically splits the CFM between the remaining registers. So if I want to add another register to my entryway living room here, automatically splits up the CFM between the remaining registers. Now, one thing you might do is you might have a room, like this hallway here, that's calling for a small amount of CFM. Now, there may be no need to put a supply grill in that area. You can't, however, take that supply grill and drag it into another space. Instead of that, what you would need to do is actually draw this hallway here as part of the entryway or part of the kitchen to be able to bring that into those spaces. So you could delete this hallway and redraw it if all of the air from that area needs to be shared with a particular room. However, as is often the case with hallways and some closets, it may just be easier to simply delete the register. Because if you delete the last supply register in the room, as the program tells us here, the program will proportionally redistribute its load between the adjacent rooms of the same floor. For example, look at my bedroom 3 and bedroom 2 here. At 92 CFM and 91 CFM, when I delete this and say yes, it's now 93 and 92 CFM. Load from the hallway has been redistributed to the rooms around it, which then recalculated the CFM in these rooms here. Now, once the registers are placed where I want them to go, now is a good time to start entering register sizes. Wrightsoft doesn't need to know the register sizes to properly calculate the duct system. However, if you want your materials list to reflect the right materials, or your printouts to reflect the right grills, you're going to need to enter these register sizes, as Wrightsoft is incapable of calculating the proper size, as we don't know what your targeted throw numbers are, or the free grill area, the Q rating, or face velocity targets of these registers. Having said that, I can group registers together. So if I want to use this, if I use 6 by 10 supply grills for anything going up and down, like this grill here, I can select them and enter 6 by 10 on the property sheet. And then for all the horizontal grills, group them together, 10 by 6. Now, in all reality, we realize that these registers with larger CFM would need different grill sizes from these registers with much smaller CFM, but for the purposes of this design, it proves the point. Right-click on the grill, change the grill size on a case-by-case basis, grouping whenever possible. You can do the same to your return grill. And with my registers placed where I want them to go, my air handler placed where I want it to go, and all of the components sized the way I want it, I can now repeat this process on the next floor of the building, trying to, whenever possible, work one floor at a time. I turn on the ducts and duct notation, drag and drop my grill to where I want it, select that grill, change the dimensions to something appropriate, add any return grills that I might want, and locate and size those returns. And speaking of returns, with that done, we're ready to move on to the next step of the duct design process, matching supply and return grills. That concludes this video on preparing the drawing screen for duct design. Thank you for your time, and have a good day. In this video, we're going to look at the process of balancing supply and return grills in Wrightsoft Universal. By default, Wrightsoft Universal will provide one return grill for every system in the design. To add a return grill, simply drag and drop from the HVAC shapes. By adding a return grill to this room here, the program will automatically assign supply grills to said return grill. The logic that Wrightsoft Universal uses when assigning the air to a return grill is simple. Wrightsoft tries to keep the air as local as possible. If there's only one return grill on a given floor, that return grill will pull back the air from any supply grills on that floor. If there are multiple return grills on a given floor, Wrightsoft will try to keep the air local, using the registers nearby. However, Wrightsoft also wants to keep the air balanced, so it may find registers further away to assign to that return grill in order to keep the return grills relatively the same size. Now, this may not be what you're looking for. For example, this return grill here in my master suite should only be pulling back air from the master suite, these three grills here. The fact that it's pulling back air from the utility room and some of the entry and living room is going to be a problem. To see what those assignments are, one need only click on the grill itself. As you can see, when you click on the return grill, any supply grills that are assigned to that grill automatically go bold, like the return. Here, these are my bold registers, and here these are the bold registers. To reassign them, simply select the supply grills that you want to reassign. You can use the Shift key, you can draw a box around them with the pointer, group them together. And along with those supply grills, select one return that you'd like to assign them to. It is very important you only select one return. You cannot split this air across several returns yet. Once you've selected the supply grills and the return grill singular that you want to assign them to, you can find this icon here, the S+R icon, or Link Supply to Return Registers button. By clicking this button, all of these supply grills are now going to be assigned to that return grill. Repeat the process for as many supply grills are incorrectly assigned, and all of the air will balance correctly. That concludes our tutorial on supply return assignment. Thank you for your time, and have a good day. In this video, we're going to look at drawing a typical trunk and branch duct system. The first thing we want to do is we want to make sure that our registers are set up and placed where we want them to go. It's much easier to edit registers before you've connected ducts to them, simply because when you start connecting ductwork to these registers, if we have a close look here, this is our register, but that is the boot attached to the register, and this is the duct attached to the boot attached to the register, and they're all sort of located in the same small place. So we want to make sure that those registers are as close to where we want them to go as possible before we start our drawing. Now, one thing that you might find particularly useful when drawing a duct system is locking the building layer before you actually start drawing it. This will help enable you to isolate the duct components here as you click and draw these items and prevent you from accidentally editing, moving, dragging, deleting, or otherwise messing up things on the building layer, which we're not working with right now. So now that my registers have been placed everywhere I want them to go, I want to make sure my snap points are turned on. These are little blue squares at each side and the center of this air handler icon and each of these registers. And this is what you'll connect to when you're connecting ductwork. When I want to connect to this return grill, I'm going to need to connect to the center of it here where the blue square is. Touching the side of it will not connect to ductwork. So I'm going to take this air handler icon and make sure it's where I want it to be. My registers are already where I want them to be. Now that I make sure my snap points are on, I'm ready to start drawing ductwork. I'm going to want to select the duct layer, which is not currently locked, before I draw said ductwork. So I'm going to click on this ducts layer here. And this icon here, the supply duct icon, I'm going to draw my ductwork across here. I'm going to start with my trunk. When doing a trunk and branch system, I've always found it easier to draw the trunk line first. So I'm going to click on the supply duct icon. We don't have a trunk icon. All duct is duct. We can figure out which one is trunk and which one is branch just by the way you draw it. So I click the duct icon. I'm not going to click in a hole, and I'm going to tap the left click button, and I'm going to bring my cursor onto my air handler here. Now I'm going to start at one of these blue snap points. It doesn't matter which one. If you want to use a separate one for supply, another one for return, you can do that. If you want to use the same one for supply and return, because you have a high supply and a low return to the same side, you can do that. If you have a zone system and you're coming off at 3 different points, you can do that. But wherever I'm going to choose as my starting point, that's what I'm going to do. I'm going to pick a starting point here. So I'm going to come off the middle, I think. Starting here in this middle, I'm going to left click and hold, and I'm going to drag a line. Now, you see how sometimes that line can come off a little bit crooked? Especially with lower snap settings, this can happen. If you hold the Shift key That will maintain a straighter line when you draw it. Now, what I like to do is I like to try to draw the trunk line past where my last register is going to be connected, or my last takeoff is going to come off, because that will show an end cap. The program doesn't actually calculate the need for an end cap, although it is documented in the Manual D. So I do like to show it for my drawings, and I'm going to continue my trunk line just a little bit past, like so. Now, if that trunk line was to have to go around an obstacle of some kind and had to turn, you're not going to bend that duct, all right? If I had to come out here, and if there was something in my way here that I had to go around at this point, I would draw my duct to that point and then stop. Then I could click on the supply duct icon again, or if, like me, you're using repeat last selection, you don't have to do that. You just aim for where you left off, left click and hold, and continue off in the other direction. And then stop again, and then pick up where you left off and continue on in the other direction, like so. And every time I draw a duct, it connects a duct, simply like that. Now, with my trunk line drawn, it's time to connect the branches. What I like to do when connecting the branches is I'm often trying to make a 90-degree angle, is start at the register and work my way back to the trunk. You see, if you start at the trunk and work your way out, it's a pretty easy thing to do to miss and not make your connection as straight as you want it. And at that point, I have a choice. I can make a straight line that doesn't connect, or I can make a crooked line, and something I'm going to have to fix. If I start at the register and I work my way back, even if I start off crooked, I can fix it and make that straight line. And again, by holding the Shift key, even if I move my cursor off a little bit, this thing is going to force me essentially into either a 90 or a 45-degree angle. And what I do is I start at this register and I just work back to the trunk. Now, it's not uncommon to actually miss your connection by just a little bit. And see right there, I just missed the connection. And when I come back to this trunk here, you see this pale color? You see these pale colors here? A pale color indicates that there is a break in the connection from the air handler to the register. So over here, it's not connected to a register, which is why it's not a dark color. The air isn't moving through it yet, right? It's connected at the air handler, but not at the register. Over here, it's connected at the air handler, and it connects to the trunk, but it doesn't connect to the register right there at the end. When you're doing a duct design, zooming in for a better look can be a very helpful tool in making sure you have those connections. Anytime you see that pale color, you know you've missed a connection somewhere, and further investigation will reveal a break in the line somewhere that you can stretch that duct to make that connection and take care of. And as I go through the rest of this system, just starting at the starting at the grill, starting at the register, holding my Shift key and working back to the trunk, the program is making these connections for me. Now here where I have two registers directly across from each other, I want to avoid creating a cross-fitting, right? And so I may offset this connection a little bit and put a 90-degree turn here, an elbow here at the end. Just like I did with my trunk, I can do the same thing with the branches. I can left click and hold, drag, draw it off, and then pick up where I left off and connect it back to the trunk, like so. And for the return side, I can do the exact same thing. Start at the air handler and connect. While it may seem like an oversimplification, for a one-story system, the general rule is wherever there's a duct, draw a duct. Wrightsoft will then connect, measure, and size each of those ducts. This concludes our video on drawing a basic trunk and branch system. Thank you for your time. Have a good day. In this video, we're going to go over how to draw an all-flex duct system in Wrightsoft Universal. Once here on the drawing screen, I'm going to draw my actual flex duct system by using the supply duct icon and return duct icon. Now, these are ceiling grills in the attic of my level 1. My air handler is also located here, although this could be in a closet coming up through the attic space and could be the top of the plenum. Remember, the plenum and the air handler are sort of the same icon here. But we'll say that this is an attic unit. In fact, I could demonstrate this as a horizontal unit simply by stretching out my air handler and using one end for supply and another end for return. It's important that I use these little blue squares here, my snap points, as my starting point for these connections. And what I'll do is using straight lines at first. Yes, you can bend flex duct, but it's much easier to connect your duct system using straight lines. Okay, so I will start with my supply duct icon. I'm going to use this as my supply side, and I'll run a duct off in this direction. Now here is where I'm going to put my first Y. Then, picking up where I left off, and zoom if you need to. We want to start right at the end of this duct right here. I'll finish making that connection. Right, I can do the same thing from here on out. Now notice there's a pretty significant difference in the methods I use to connect a flex duct system and a trunk and branch system. Usually with a trunk and branch system, I'm starting with the register and working my way back. I find it easiest to work out from the air handler and connect to the registers when doing an all flex system. It's not the only way to connect it, I just find it to be the easiest. So I'm going to start with my supply duct icon, come to here. Then make my connection. And anywhere I want a duct, I'm going to draw a duct. Starting at that same point. Now maybe out here I'll do a junction box, as I have 3 equal supply grills. By connecting back to this same point each time, the program will automatically create a junction box for me there. I can do the same thing in here. I can do the same on the return side. If I want to create a riser up to my level 2, I simply run a duct to wherever that riser is going to be. Again, using straight lines. Even if I'm creating some crisscrosses here, I'm going to start with straight lines. Select the fitting and designate it a riser. Tell it how far it needs to go. And connect the duct off of there. Oop. I want to make that connection. If I don't need a riser, I just need to make sure that my duct is going on the floor that I want it to be on. And make the connection. Now we all know that this isn't what my flex duct system is going to look like. This run here is going to try to go around that register. This run here is going to try to go in between these, and so on. And so what I'm going to do is I'm going to click on the flex duct itself. And as long as that duct is connected, we have that nice dark color, I can turn on my edit points icon and move my flex duct around. I can put a bend in the flex duct. I can take this duct here and bend it around. All right, I can take this duct here for a more realistic depiction of this system. I want to come off at a steeper angle here, come off of here at a different angle. This connection here would come off a little more to the side, and make whatever adjustments need making to accurately depict this system. This concludes our video tutorial on drawing an all-flex duct system. Thank you for your time, and have a good day. In this video, we're going to look at some of the instances of having a multi-story duct system within an attic. If this duct system here is within my attic space, and this bonus room here is also built inside the attic, I should be able to connect this ductwork straight from here to these registers. The issue here is that this register out here is actually reached by going over and above and into the truss space above my bonus room. So I'm going to need a vertical duct to do and show that. And the way I'm going to do that is I'm going to create a riser. if this duct system is in my attic space, I shouldn't have any serious obstacles to worry about. But if I did, if I needed to see where this duct would run, where I would need to put my ductwork, I might have 2 floors turned on to do this. If I need context from my other floor to tell where the duct will go, I'll leave both of these floors turned on. If I'm able to determine where that riser is going to go, where that vertical duct is going to go without looking at my level 2, then I can turn off my level 2 and start drawing the ductwork, the portion that starts on this floor, that starts in the attic above my level 1, without looking at my level 2. Now, I'm going to do it the harder way. I'm going to have both of these floors turned on at the same time. Now, the reason that this is the harder way is you have to pay very close attention to what layer is selected. There's a reason why our duct system is color-coded by floor at first, and that reason is simple. You can tell when you've accidentally drawn a duct on a different floor. When the duct shows up like this as a different color, like so, I can tell that I've drawn it on a different floor than the one that it's on. So I'm going to start by drawing my ductwork on my level 1, meaning I have to have the level 1 duct layer or one of the other layers on level 1 highlighted. Now, if my vertical duct is going to start just on the floor of the attic and just come straight across before it turns up, I'm going to draw a duct to that point where it turns up. Now, once that duct is drawn, there is a fitting at either end, and it's the fitting that I'm interested in. Any fitting can become a vertical duct. I can create a boot that's a vertical duct. I can use an elbow or a fan fitting or a takeoff. Any of these fittings can become a vertical piece of duct. I'm going to use this little end cap fitting here, which should be noted is not a real fitting at all, but until other ducts are connected to it, this is a generic fitting icon that we use to make it look like an end cap. Now, if I right-click on this little guy here, the very first question on the property sheet for this fitting is a riser. Now, some would argue the hardest part of actually getting to this step of creating this riser is right-clicking on that fitting, which is why it can help to zoom in if you're having trouble. Once I've right-clicked on the fitting, is a riser, I'm going to answer yes, it's a riser. Now, is existing, remember that's about whether or not it's an existing components for the materials list, and the vertical duct length. So you get to determine the vertical duct length. We don't know how far this has to go. We don't know whether this system is in the attic or in the crawl space, whether it's going above or in between the joists. So that's for you to determine. You determine how far it goes. But my vertical duct length, I'm going to set here for 11 feet. And the starting sheet starts on level 1, and the ending sheet ends on level 2. The order here is not important, but the making sure you have the right 2 floors certainly is. And the duct shape is going to determine whether you're using rectangular stack or wall stack if you use a stack duct. But I won't be able to make adjustments to this until the rest of the ductwork is connected, as this is still a pale color and the ductwork is not sized. But you can see the icon itself has changed. Instead of looking like an end cap, it looks like this symbol here. In an X for supply, it's showing a 2 different color X here, indicating that it's connecting the 2 floors of that color. Now, when I go to my level 2 ducts, in fact, I don't even need level 1 anymore. I could turn that off. And when I'm looking at level 2, you see I can see that riser icon there. And I can use my supply duct starting at the riser and continuing on to this register. Now I'm going to right click on this duct and I'm going to make it flex duct. Right? And I can use the edit points on my flex duct as we showed you before. And if I turn on my level 1 and look at this, you can see the duct starts off at the trunk, comes over, turns up, and then continues on the next floor. Now if I right click on this duct, this component here, right, I could use my trick where I start a new trunk and I could change this duct material here to sheet metal. And because of the different coefficients of friction, right, because this is flex duct and this is sheet metal, I now have 2 different duct sizes. I might turn off automatic sizing so I can run a 10 over to this. But along these same lines now, if this return here in my bonus room is a low wall grill, right? And this duct system here is in the attic space above my level 1. And this is a low wall grill on the floor above it. I don't need to create a vertical duct to connect that, do I? Right? This could continue across the attic floor and then connect to this wall. And Wrightsoft will let you do that. We have more information on this style of duct connection in our basement multi-level duct system, but if I make sure I draw this duct on the correct floor, if this is where my attic is, then this is where I want to draw that duct, on level 1, right? Drawing it on level 2 would, in this instance, mean that I'm coming across the top of that attic space rather than the bottom of it. For more information on that, see our video on changing the attic duct system to a crawl space duct system. This concludes our first video on multi-level ductwork. Thank you for your time, and have a good day. In this video, we're going to have a look at how to move this attic duct system into a basement. Now, in order to save time, I've already drawn our basement here. Now, the first thing I want to do is make sure that my duct load is correct. Since the location of my duct system is going to be different, I want to make sure my rooms are calculating their duct system in a conditioned space. So I check, again, that's on the Room tab of the Room Property sheet, and I'm going to want to check this for both my level 1 and my basement. And change the location of my duct system to conditioned space. Now this is going to take the duct load for these areas down to 0. Next, I should double check the load of the building to make sure that I'm still within the right range in terms of the equipment that I've selected. If any changes need to be made to this equipment, I make whatever adjustments need to be made on my equipment selection page, including my CFM and static pressure. Along those same lines, if something is changed about that static pressure or CFM setting, I might want to revisit my static pressure page, as more airflow might cause a greater amount of resistance on my filter. Next, I should revisit my duct preferences page. I might be using different boots or different fittings. I might be using top takeoffs instead of side takeoffs in a basement. And again, making any adjustments to this duct preferences page will automatically adjust any duct or any fitting or any part of the duct system here that hasn't been manually changed. So as long as I haven't made manual adjustments to any of these ducts or any of these fittings, making a change here on the duct preferences page will affect the entire design. Now it's time to actually move the duct system down to the basement. I can start with the air handler. If I right click on the air handler, I can change the sheet location from level 1 to basement. Now technically speaking, the basement and level 1 share a space. I don't need to move this air handler or these ducts to the basement. The floor of the first floor and the ceiling of the basement are the same space, and Wrightsoft will allow me to draw my system here. That having been said, for common sense purposes, most people, when they look at a system that's obviously installed within the confines of the basement, want to see that duct system drawn in the basement. So I'm going to move this air handler location to basement. That moves it down to the basement layer. And I'm going to move all of these ducts down to the basement too. I can actually do that fairly easily by using my global selection tool. You see, if I select all of my supply ducts, on the property sheet of those ducts, I can change the sheet from level 1 to basement. And now all my ductwork is in the basement, at least for the supply. I can do the same for the return. Select return ducts and locate all of my level 1 return ducts to the basement. Now with all of my ductwork in the basement, and you can see the connections to these registers on the first floor are still being maintained. Now they give us this little icon here, these little boot fitting icons, without showing the register, because I'm currently hiding my level 1 where those first floor registers are. But Wrightsoft will allow me to connect a duct from one floor to the register of another. You see, as my basement duct layer is selected, I can click on the supply duct icon and draw this duct on the basement layer, but connect it to a register on level 1 with no problems whatsoever. Now by turning off level 1, I still am going to need to connect the registers here in the basement itself, like so, and like so. In fact, the only major step I need to worry myself with now is our risers. This duct is a riser. I need to make sure it's going the right distance to get from my basement up to my level 2. Right? And that distance might be 20 feet. The same for my return as it goes upstairs. Is this a riser? Yes. What distance is it going? I also probably shouldn't run that riser into the dirt. Now that explains how to move your duct system from a previous crawl space model to one that has a basement that you've added. For more tips on how to draw a duct system in the basement initially, rather than move it from another design, see our video for designing a basement duct system with high wall returns. In the meantime, that concludes this video on how to move a duct system from a crawl space to a basement model. Thank you for your time, and have a good day. In this video, we're going to look at some of the tips and tricks for drawing a duct system in the basement with high wall return grills. The first tip is, whenever possible, I try not to look at both floors at the same time. It can be an overwhelming amount of information and sort of difficult to see what I'm doing. So I try to deal with things one floor at a time. The first thing I try to do is place the registers where they're going to belong on the first floor. As typically you're going to be more constricted and more constrained by where you can put those grills. All right, so establishing the location of these supply grills and these return grills here. I'm using wall grills here in my hallway in my master bedroom. And then what I'll do is turn on the basement layer so I can see my basement floor here. Now while I have the basement layer turned on, I'm also going to turn on level 1. But as you can see, things get very cluttered very quickly. It's hard to tell what goes where. And then what I'll do is I'll turn off the building layer on level 1. You see, I don't need to know where the walls and ceilings and floors and windows and doors are on my level 1 anymore. I'm going to be dealing with the duct system. And the duct system is primarily going to be located in the basement. All I really need to know is where those supply registers go in relation to that basement. And so by hiding the building layer at level 1, see, now the only thing I can see here are the location of these supply grills. Now my favorite trick when doing this is one that we use in other places in the software. Whenever I want to see something, but I don't want to accidentally edit it, I lock it. So I right-click on the duct layer for my level 1 and lock it down. These supply grills and return grills are located where I want them to go. So by locking that layer, I help prevent myself from making mistakes. I might even choose to lock the duct notation layer or simply hide it so that I don't accidentally edit anything on my level 1. My greatest enemy right now is accidentally drawing something that I intend to be in the basement on the first floor. By locking the components on level 1 that I don't want to accidentally draw on, it eliminates my ability. Look at my HVAC shapes. It eliminates my ability to draw on level 1. With the location of these supply grills, I'm going to choose locations for these supply grills in the basement that makes more sense, right? I choose locations here that it's going to be easier for me to connect this ductwork, as I probably have more wiggle room for the location of my basement supply and return grills. Once I've had a chance to choose the location of these supply grills and return grills for my basement, I'm ready to draw my duct system. Connecting this duct system is as simple as connecting a regular duct system. Draw your trunk, connect your branches, just make sure you do it on the right floor. Because while Wrightsoft will allow you to connect the duct of one floor to the registers of another with no problem, it won't allow you to connect the duct of one floor to the duct on another floor without using a riser. So if I draw a branch on my level 1 and the trunk in my basement, and you see I have to unlock that to make that happen at this point, the program won't connect that duct. See, it needs a riser there to get to level 1. So all I need to do is make sure that all of the ducts that I draw stay in my basement, and I can connect to those level 1 registers without any issues whatsoever. It's simply connect the dots, making sure I connect these branch runs here. If I have to 90 over, I can do so. And the only other trick to doing this design is the fact that two of these registers, in fact, are going to be high wall grills. So what I'm going to want to do when I'm connecting these registers is connect them the way I normally would, as if they were simple floor grills. Right? I could draw a trunk, if this is going to be a trunk and branch return, and run branches back to that trunk, like so. This register here is a ceiling grill in the basement. I don't need to worry about that one. But these registers here, these are actually risers. This is going to go up a wall and into some wall stack for a high wall return. That means what I need to do is I need to select the boot connected to that register. If my duct layer is locked on my level 1, it actually makes it quite easy for me to do. But what can make it even easier is if I just turn off my level 1. You see, now that the ducts are connected, these boot fittings, these show up as nice big targets for me to click on. Right? And if I select one of these boot fittings here, I right-click, I can make this a riser duct. All right? And when I make this a riser duct, I get to tell it what the length is. So how far up the wall is this thing going to go? The program automatically chooses the fitting here, which I can then select as a high wall stud cavity return space. I can also choose an elbow for my second fitting. In addition to that, I can make adjustments to the riser duct itself. And by default, it automatically calculates as simply part of the branch run. But I can change that to a separate piece of duct and size that duct as 3-inch wall stack. And I can do the same to my other. Create a riser, tell it how far it's going, change my fitting selections, add an elbow, and make adjustments to my riser duct. That concludes our video on basement duct systems with high wall grills. Thank you for your time, and have a good day. In this video, we're going to look at some of the steps for editing or fine-tuning a duct system. First, we'll start with this duct over here, where I have a sheet metal branch coming to an elbow before I reach my register. Now I might decide that instead of sheet metal duct and an elbow, that I want to use flex duct to do this. And so I might get rid of or delete that duct there, and instead connect this with a straight line. Now, as you'll see in our radial system or flex duct system video, we recommend that when drawing your flex connections, you start with straight lines before you start bending the flex. It's a lot easier. Now, the problem here is I don't want all of my branch runs to become flex duct. I just want this branch run to become a flex duct. And so by right-clicking on that duct and that duct alone, I can look at the properties for this duct. And I can see that right now it's sheet metal. Now, if I change this property here from sheet metal to round flexible vinyl, I now have flex duct. Note that the size of the duct changed automatically to account for the higher coefficient of friction, and that the icon that we use for the duct became a squiggly line designating a flex duct. Okay. Now what I can do with this duct is I can now that it's flex duct and make sure it's connected, by the way, my edit points tool lights up. And I can click on that edit points icon there. And when I hover my cursor on the duct, I see my add edit point icon. If I hover my cursor somewhere along this duct, doesn't actually really matter where, left click and hold and drag, I can bend that flex duct like so. There are other things I can do to edit this duct system. Let's say here where my trunk line elbows over to move out of the way of an obstacle. Let's say I didn't go far enough or I went too far. If I try to move this trunk line, moving it piece by piece is going to be difficult. So I'll have to move that piece, then I'll have to delete this extra piece here, then move that down and move that down, or I'd have to delete whole sections of it. It can be rather difficult, which is why we have this icon here. It's called our special trunk moving mode. Okay, and if I turn that icon on, what it's going to do is it's going to encourage the program to keep the trunk together. And so if I move one piece of the trunk line, all of the other pieces down and upstream are going to try to move with it as best they can, making it easier for me to reposition a trunk without having to delete whole sections of it or do it one at a time. It's generally advised you only use this mode when you're trying to move a section trunk as I have here. There are other things I can do from the duct property sheet as well. By right-clicking on a duct, in addition to changing the duct material, I can change the insulation value that we use on the materials list. I can even determine whether or not I want this duct to be automatically sized. If I turn automatic sizing to no, I can then manually change a duct size. Now this can come in handy in a few situations. For example, if I wanted to run a duct that started off as sheet metal but ended as flex, there are a couple things that I can do to do that. First, it should be noted that if you're not using Wrightsoft's materials list, determining how you want to size that duct, as a sheet metal duct or as a flex duct, might determine how you want to do this. In other words, if you're just doing 5-foot flex ends and you're going to size that run as if it were a flex duct, then changing the entire duct to flex wouldn't change anything about your design. This would remain, see if I change this to flex duct, this would be an 8-inch duct regardless. I will talk more about those duct sizes later, but if you're going to use the flex duct size throughout and you're not using our materials list, then there's no substantive difference between running sheet metal to that flex duct or running the entire thing as flex. Now, if you do want to show this for purposes of inspection or installation or because you are using the materials list, then you would want to draw this duct as 2 pieces. Draw the first piece to the length that you want, and then finish the connection. Now this duct is going to size as one continuous piece of duct initially, but it is considered 2 separate pieces of duct. And technically speaking, this duct here, as it connects at both ends to another duct, is considered a trunk line. Now, one thing we haven't looked at on our property sheet is one of the unique properties to a trunk duct. On a trunk duct, we have an option that says Start New Trunk. Now, if I choose the Start New Trunk option, I can say, yes, I'd like to start a new trunk. Now, by default, this is going to use, see it went to an 8-inch duct, it's going to use our trunk duct settings. But I have the ability to individually change these components. You see, first, I can change this piece to flex duct, as I intended. Take this duct here, and by starting a new duct, I can now change automatic sizing to no. And I can make this a 7-inch duct. Another common thing you might do while editing a duct system is adjusting individual fittings. If the majority of your boots are straight boots, but a few of them are parallel or torpedo boots, you might want to make adjustments to those individual boots. Simply right-click on a boot, or any fitting for that matter, and you can manually make adjustments to what kind of fitting you're using there. Now, it should be noted that any fitting that you manually adjust or override will not change if you should change your duct preferences later on. This concludes our video on editing a duct system. Thank you for your time, and have a good day. In this video, we're going to review the last step of the duct design process, namely checking your friction rate and static pressure page. One of the issues with this particular duct design is that I'm using fairly large duct sizes. A 7-inch round sheet metal duct for 86 CFM is certainly out of what most people would call the standard range of sizing a duct system. But there's nothing wrong with the software. The reason this duct is sizing so large has to do with our static pressure page. Now, if I come here to the static pressure page, I can go to duct page of the navigator bar and go to static pressure. I can go to the show menu, go to Write D, static pressure, or my little blower icon. And when I look at the static pressure page, I can see that the total effective length of this duct system is 484 feet. Now that's the actual length of supply branches, supply trunks, return branches, and return trunks, plus, and this is what gets you, the equivalent length of each of the fittings the air has to go through for each of those runs. With 484 feet of equivalent length, an available static pressure of 0.19 inches, that brings my friction rate to a meager 0.039. Now, the acceptable range for manual D is above 0.06, thus the indication here that our friction rate is less than 0.06, or below 0.18. So with this friction rate too low, I need to make an adjustment. Now, I don't want to override my friction rate. If I override the friction rate, the program will size the duct system with sizes that make more sense, but it will mask the underlying problem, my very high total effective length and my fairly low available static pressure. Now, the first thing I'll probably want to do is see if I can shorten this length number. Now, the way I can do that is try to create straighter runs. If this dogleg turn here in my trunk line is unnecessary, then I want to straighten it out. Or if there's another way to run that, I could do so. Perhaps I could run a separate duct to my riser that goes upstairs. Or maybe I could bring some of my return duct in as more of a home run connection rather than a trunk and branch connection. Or perhaps I could simply use less restrictive fittings. I could try to use fan fittings that have tapered takeoff or transition. I could use elbows with a wider radius and lower equivalent length. I could use takeoffs with those same transitions. And most certainly, some less restrictive boots. And remember, changing your fittings on the Duct Preferences page will automatically override any fittings that you haven't manually changed on your own. And that in turn will bring down this total effective length. And you'll see that my friction rate starts to come up. I'm still not above 0.06, but I'm getting closer. And if I look at my drawing screen, I now have a 6-inch run here where I had a 7-inch before. This run is still a 7-inch duct, however. As I look at my static pressure page, I see that there are basically two halves to this equation. There's the total effective length, which is the layout or geometry of the duct system itself. And a lot of time that's going to be defined by the actual building, where you can actually fit a duct. If there are options of using straighter runs or fewer turns, you should most definitely take them. But once you've exercised those options or exhausted those options, your next best bet to lower this number is to use the best fittings that you can afford to use for this job. Once that's been done, the only other side of this equation that I can affect is the pressure. If I have access to a filter that has lower pressure loss, I should consider using it. And as that would increase the available static pressure, that would increase the amount of resistance my ductwork could then put on the fan, because my filter won't be putting that resistance on the fan, it allows me to make my ducts even smaller. And again, my friction rate goes up, and this time reaches the range of above 0.06, which gives me literally the okay here from Wrightsoft. And as I go back to Wright-Draw, I now see I have a 6-inch duct on 86 CFM. Now, 0.06 might be much lower than you're used to as a friction rate. We here at Wrightsoft do have customers who like to use a greater friction rate on their designs. You can do that, but it comes at a cost. I need to have more available static pressure or lower total effective length. It's possible that the fan that I've selected, whether it be a furnace or an air handler, is rated at 0.5 inches of static on a medium or lower speed, that I might be able to go to a higher speed and deliver the same amount of air. By overriding this field, I can adjust this number up. Perhaps at high speed, this fan will deliver the airflow that I need at 0.7 inches of static pressure. At 0.7 inches of static pressure, my friction rate goes over 0.1, which is a commonly used residential design setting. So I probably don't need to go that high. I could try 0.6. Well, that puts me right in between the common numbers of 0.08 and 0.10. That gives me a friction rate of 0.9. Maybe that's what I'll use, or adjust it up a little higher. Let me be clear about this point, however. This comes at a cost. If your fan is not designed to be able to move its airflow, the airflow that you need to do the heating and cooling you need to do, at this higher resistance, you're going to lose airflow by designing your system to experience more resistance. You can see that these runs here, closer to the air handler, are sized at 5-inch runs rather than 6, now that I have this higher friction rate. So in conclusion, if there's something you're not sure of, or something you don't like the look of in terms of your duct sizes here in Wrightdraw, it all has to do with the static pressure page. Your friction rate is a mathematical representation of those duct sizes. It's the number you would use if you were using a ductulator. What the Manual D is doing is it's calculating what that friction rate should be based on the measured total effective length of your system and how much resistance from your ductwork your fan can handle. If you have less effective length, you can use smaller ducts. If you have more available static pressure, you can use smaller ducts. You have options to adjust these parts of the design by using better fittings, straighter runs, or perhaps a different fan speed or different fan altogether. This concludes our video tutorial on checking your duct sizes and using the static pressure page. Thank you for your time and have a good day.